So today's topic is to understand the Newton laws of motion. Newton's laws. There are 3 of them. These are for motion. Newton also did some other laws for other things. So one of the explanations is that some of these laws, they seem so straightforward, but when they were discovered, they were actually revolutionary, these laws. So the first law, which is called the Law of Venetia, implies that things cannot start or change direction all by themselves. Meaning for something to move, there must be a force that was applied. Things do not move on their own. So the property that resists, the property of bodies to resist changes in their state is called inertia. So that's what you say. What is inertia? You say it is the massive, it is the property of massive bodies to resist change in their state of motion. So that's what you say there, if someone asks you. So this law is also called the law of inertia, because inertia, as we have said, is the tendency of a body to resist change. So now we read it, this thing, to say a body at rest or in uniform motion will continue to be at rest or in uniform motion unless an external force acts on it. So the key word in Newton is that when there is zero net force, when there's zero net force, when do you get zero net force? When your forces are all balanced, then your body will be moving at constant velocity, and that velocity can also be zero velocity. So meaning, if you hear that a body is moving at constant velocity, that's very key now, I have to say that. If you hear that a body is moving at constant velocity, it means that that body that you have should either be moving, it means that body that you have has forces which are balanced. So when forces are balanced, you get equilibrium. So what are the 2 equilibrium positions that we have? Either a body will be at rest, meaning it's not moving, or it will be moving at a constant speed. So when a body is moving at a constant speed, then the net force, which is the summation of forces, remember when you're adding forces, the force to the east is positive, force to the west is negative. So if the force to the east is equal to the force to the west, it means that body should move at a constant speed. So meaning there's a balance there. So that's what we mean there. If the upward force is equal to a downward force, then the body must be resting. Why? Because there's also a balance of forces. So once forces are balanced, then they will either be constant velocity or zero velocity. So meaning for us guys, constant velocity is a state of equilibrium position. If a body is moving at a constant speed, then it is at equilibrium, meaning all the forces are balanced. So one of the key things that I will insight on as we talk about these things is that if your friction is equal to the applied force, the kinetic friction is equal to applied force, because those are the things we'll move to. If the kinetic friction is equal to the applied force, then you have equilibrium. So we get back again to vectors. We get back to vectors. So we'll solve some questions. I'll show you some of them that we solved in vectors. where we were solving some ropes like tied to a ceiling, and then there was a tension there. That was also Newton's first law. That was equilibrium, meaning for equilibrium, the forces are balancing. So when we say the upward force is equal to downward force, it means we are saying there is no net force. Then there's zero negative force. Then the next point is to define inertia. Inertia as the tendency of a body to resist change in its state. It is also the measure of an object's mass. So remember, guys, even when we're talking about inertia, this one, the nice definition here, where we said the property of massive bodies, meaning the bigger the mass, the greater the inertia. Meaning the bigger the mass, the greater the inertia. So the net force is actually called the summation of forces. That's why I said if you want, you can even write this. Someone says state Newton's law, then you say if the summation of forces is 0, if you don't want to write summation just means you're adding this force plus this force that acts on a body. If the summation of forces is 0, or the net, F net, is 0. So F net is the same as the summation of forces. The net force is also the summation of forces. So if that is 0, then the body is at rest or at constant speed. If the forces are like that, so we'll look at the differences. When we start defining friction, there is friction, static friction, and kinetic friction. We'll look at those. So when you look at them, you come and understand what we're talking about. When you are pushing a drum, it's difficult to get started because the first friction that is there is static. But then when it starts moving, you discover that it's easier for you to move because the friction changes from static to kinetic. So that, my friends, in essence, is Newton's first law. So Newton's first law says if the net force is 0, then your body will move at a constant speed. Are there any questions on Newton's first law? All right, then I can move to Newton's second law. So there are so many statements on Newton's second law. Opa, the second law of motion describes what happens to a massive body when there is now an external force. Remember, guys, the word external force in the first law is the one we're calling the net force. So the external force is that force here, Pulamo. So if there is the force number here, Pulamo, there is no balance. So that's what we mean. If the forces, when you add them, they are not giving you 0. That's what you look at when you are looking at Newton's second law of motion. So the second law of motion states that the force acting on a body is equal to the product of its mass and acceleration. You can say that. There are so many statements. So the other statement is this, the second one here. The acceleration of a body, of an object, produced by a net force is directly proportional to the magnitude of the net force. So if a net force is producing an acceleration, so it's directly proportional to the magnitude of the net force in the same direction as the net force. Meaning net force not wasanga acceleration is upward, but nishi, the body is moving east. So the acceleration for the acceleration which is direct proportional is that one in the direction of the net force. So it's the one that is produced by the net force. It's direct proportional to the net force and inversely proportional to the mass of the object. And inversely proportional to the mass of the object. Meaning, the bigger the body, the more force you need. That's what you mean when you say inversely proportional. The more net force you need to accelerate that body. And the bigger the body, the less acceleration you expect. If you are applying the same force to different bodies that have different masses, the one that will move slowest is the one which is big. So this is the case. So this derivation comes also from the statement that says net force. So aka F akadi so aka nika net. Net. So F net is direct proportional to the rate of change of a body's momentum. It refers also to the body's what team? Momentum. Momentum is the product of mass and velocity. Mass and velocity. But now we're talking about the rate of change in momentum. Change in momentum, in fact, guys, we'll look at it. It's called impulse. It's called what? Impulse. So if the momentum changes, means only the velocity changes, because the mass of a body is always intact. So when you push something, then it will have an initial velocity, which is u, a final velocity, which is v. I just got them like this. I didn't choose v naught. So this one, mass times v minus mass times u, so which is mass times final velocity minus mass times initial velocity over the time, is proportional to the net force. Then when you solve this, you discover that the mass here is common. So you factorize it. M, then you get v minus u or over this over t. You discover that v minus u over t is a. So F net is direct proportional to MA. Proportional, when you remove this proportional symbol, you put a K. So you say F equals K MA. So this K is almost equal to, always equal to 1. The proportionality constant by experimentation has been found that it is equal to 1. Why? Because when they got a 1 kg body and applied a 1 Newton force to that 1 kg body, they are on a frictionless surface. It was discovered that the acceleration was also 1 meter per second. So if these were 1, 1, 1, also k is equal to 1. So meaning the expression there is that F net is equal to MA. When you're using SI units, F net is equal to what? MA. That's why the units of force, instead of just being Newton, can even be kg meters per second. So here when you are finding now acceleration. So how do we find this? If there's friction and there's an applied force, you subtract out all the forces that are opposing to get the F net. Then that F net will be equal to MA. I'll give you a tutorial sheet and you'll see that these things are very straightforward. Are there any questions here, guys? Are there any questions? Chongo.
Yeah, that a small f stands for friction, or it's also a force.
Net force. In this case, it's a net force. But it's a good question because in most cases, Mr. Chongo, friction will use this F, aka F. But if it's part friction, but F na K subscript, then we will know that this is friction, kinetic friction. That will about F, that will be S ka subscript, that is static friction. That will be friction, yes. But in this context, this one is the net force.
Okay.
Okay.
Now for sir.
All right. Jackson. Montete.
Yes, sir. What is the difference between net force and applied force?
The
The
net.
difference between net force and applied force.
Okay, that's what I want to answer now. So the net is the summation of all the forces that are acting. The applied force is the force which you are acting, you are applying on a body. Then if there's friction, which our friend Chongo said, it will be opposing. So to get the net force, which is the summation, because you're saying the applied force means it's going east, maybe it's 10. Then friction is maybe 4 going west. So when you subtract what is 10 minus 4, the answer you get is actually 6. So the 6 is the net force. I'll explain them as we not sana key. I'll give you some notes and you'll see the difference. So the net force is actually the difference between the applied force and all the opposing forces that are there. Are you getting it? So if a body is falling with a weight, say 10 Newton, then there's air resistance, say 5 Newton, then the net force will be the weight which is dropping it down minus the opposing force, which is the air resistance, which is 5. So the net force will also be what? 5. So that is actually just the difference. So the difference that the net force is the summation of all the forces. And remember, when you're saying summation, we're talking about adding them, positives and negatives. Those going east are positive, those going west are negative, those going up are positive, the forces up are positive, the forces down are negative. With that context. Thank you very much. That's a very good question.
Okay, thank you, sir.
Yeah. Any other question, guys? Any other question? Because most of the work, despite Utman not talk about if so, most of the work which we will do will be based on Newton's second law. Because our job, the struggle, is to find maybe the acceleration, and more importantly, to find this one that our friend had asked, the net force. So there will be so many forces that are there acting. There will be a table, a pulley. Then your job as a physicist is to find the net force. It's actually tedious. Sometimes you even find yourself doing a simultaneous just to find the net force. So these are not like, they are very straightforward, but they are so detailed. There's so much demand on this. Monday.
Sir, sorry, I joined late. Can you kind of start from second law of Newton?
We're explaining to say that the second law states that it's F net equals MA. What is F net, Madam Monde? F net is the net force. What is the net force? It is the summation of all the forces acting on a body. Then for the first law, which was there, we said that for the first law, if there's no external force, which means if there's no net force acting on a body, when all the forces are balanced, the force to the left is the force to the right is equal to the force to the left, then the body will either be at rest or moving at a constant speed. So constant speed and rest, those are equilibrium positions.
Yes, sir.
Then
Yes, sir.
Apani there, apani there. Mbikirat E. But mwebe nife as muntu for the school malaysia ta ini there ashiranda poem. So that's the case. So we move to Newton's third law of motion. Newton's third law of motion. So that one describes what happens when a body exerts a force on another body. a body exerts a force on another body. Nasaisanga badai bomfena kuchechi in Newton third law. I found it badai bomfya. Kudishima people abaku kupende. Alirondora padi, to every action there's an equal and opposite reaction. Almost saying like life has consequences. More important. And life has consequences. No, when you plant, it's even physics alirondora. No assembly physics ni nebo ndio physics ili muchechi. So that's the thing. So the third law is very simple. It states that to every action force there is an equal and opposite reaction force. So what that means, the biggest example is when you have your phone resting on a table. When the phone is resting on the table, it will exert its weight on that table. Are you getting, guys? If a phone is resting on a table, it will exert its weight on that table. And conversely, the table will also exert an equal force equal to the weight. That force, if a table is flat, like our flat tables that are there, that force is going to be equal to the normal force. That force is going to be equal to the normal force. I'm sure you remember in your grade 12, you defined the normal force. So forces are different, guys. They're different forces, just like hair on our bodies. Hair on our bodies, depending on the location of the hair, it has a different name. It's the same thing also with force. Forces are different depending on the application. So the normal force is a perpendicular force to the surface, which is exerted by a surface on a body resting on it. So that's a thing. That's a normal force on a body placed on it. So the normal force is always at 90 degrees with the surface. Then there's also friction, which is a force which opposes motion. Friction, very important force. Without that opposition to motion, we would all be sliding. But friction is the reason why we can move, stop. So that's the thing. So in that case, for Newton's third law, it deals with the interaction of bodies. Everywhere it's interaction, because even when you are pulling, there's the interaction there. The force which you are applying yourself, and the body, there's interaction. But then now, everything that is acting on a body comes in the picture. So when two bodies interact, so to interact, interact to that's not the interact we use here. To interact for us now means that the bodies are in contact. Interacting. So when the bodies are in contact with each other, that is the interact, they will apply forces on each other. So every time there's a force, that's why sometimes these things can even be used in a church. When you are with your friend, she will be exerting some energy in you. Now, we know that exert energy more. So you should be careful with the kind of friends that you make. So every time when bodies are interacting, they exert opposite forces which are equal on each other. So now by perane in an example, babi kerana senda padi phone mena wanda pe book, because this is school. A book will apply a force equal to the weight on a body. That's the case with the book. Then when it does that, when it does, the table will also exert a force back on the book, which will be equal and opposite. So interacting bodies, as we have said, it has to do with it. The third law of motion also has to do with the conservation of momentum, where we say the momentum before is equal to the momentum after. or where we say that when bodies are colliding, because in collisions, the biggest parameter that we look at is momentum. Momentum is the product of mass and velocity. More important, the product of mass and velocity, that is what momentum. So that's what we'll look at. So we'll look at momentum later as well. So to summarize the Newton laws, there's this chart. I wish it was bigger where I was cropping, but it was small. That was unfair. So there are 3 laws. First law is known as the law of inertia. Objects at rest stay at rest. Objects moving keep moving with constant velocity unless acted on by an unbalanced force, which is the unbalanced force in this case is the external force. So these two are equilibrium, moving at a constant velocity and also at rest. Those are equilibrium. Newton's second law, it's the one we apply the most. Kai iyi ni reason ni wapofi. Kwa hiyo wanaokupeana force hii ikulu. Kwa sababu the friction is 90 Newton. The applied force is also 90 Newton. At how fast will the body move? The information options or a body moving at a body moving at 10 meters per second is acted on a surface with friction, with kinetic friction 90 Newton is acted on by an applied force of 90 Newton. What will be the speed? So mweba temukusova kwamba okusova no physics te kwamba fedionzo okusova no. What you know, you start reasoning. You say, what I've been told is that this thing is the forces are balanced. So when the forces are balanced and it's already moving, it means it will continue to move at that constant velocity. Nishwa wakwata no kwata answer because you answer nishwa bika no kubika. My answer is what? Is the same 10 meters per second. Then the Newton's second law. Tugomvya sana guys, tuwaivomvya bad Newton's second law because job yesu isamukuba mukufanya net force. If force F equals ma mwalichaile pona msugu is the F net is not always easy to find. It's not always easy to find. So always when there's F equals F net, to find it, there are so many forces which you have to find and then add this force, then wasanga net force. Physics ikwata sana application, second law. Mambale? So more force means more acceleration, more mass means less acceleration. This is inverse and direct proportional too. So when things are direct proportional, when you increase one, it means the other one will also be increased. So, but if the case is that when something increases, then the other one is reduced, then that is inversely proportional. Then the last law is called the Newton third law. It's also known as the law of action and reaction. The first law is called the law of inertia. Second law tayako ajana nickname. Golefactua itafati law of acceleration. Because second law of emusangwa fi acceleration. You can call it, some people have desperately called it the law of acceleration. Because kaifensana fi nickname. So for you to get an acceleration, then your forces are not balanced. For a body to have an acceleration, then the forces acting on that body are not balanced. Why? Because when the bodies are, the forces are balanced, then you either get constant speed, which you get the first law, constant speed, or no motion at all. So acceleration only comes in when there's a net force. That's okutira saa ndefu okwishuba what the net force is. Jackson.
Yes, sir.
Yes.
I've got a question. Why is if you were to be asked, for example, an example, why is Newton's first law of motion called the law of inertia? What can be the explanation?
Kai, when we defined inertia is the tendency of a body to resist change in its state. So that's why it's called the law of inertia, because there's always that resistance to change the state. A body in its own nature, depending on its mass, will always resist change. It would love to be the way it is. But then, because of this property, so this property of inertia determines how you'll be able to change the state of a body. To get a body started moving, yes, so that it's very difficult, because there's always, depending on the nature of the body and its mass, it will always oppose, it will resist a bit. Even you, sir, Mr. Mutete, to change you, it's very difficult. You start justifying. But I don't so change is
Yes.
always resistant. Are you getting it? So bodies always resist
I'm getting.
that motion. You've read the bit, eh?
All right, thank you.
All right.
Thank you very much, sir.
You're welcome. The last one, as we said, life in a draw game. If you punch in the wall, Moffat, yes.
Yes, sir. So you said that if the forces acting on an object are balanced, that means there is no acceleration. But earlier on, again, you gave us an example of a body moving at 10 meters per second.
Nasira pera example, a body is moving at 10 meters per second. The kinetic friction is 90 Newton. The applied force is 90 Newton. What is its final velocity? Equation. So abengi abantu balamba okusolva bamofa tebamba okusolva kwati badishi basaninza mushi mwambale, but imwe mwebeshi besikulu mwamfat applied force na friction fidi equal. So these forces are balanced, meaning when you add the positive, which is the applied force, positive 90, plus the negative 90, which is the friction, the answer is 0. So the fact that the answer is 0, the body will continue to move at the same speed of 10 meters per second, meaning the velocity will not change.
Yes, sir.
Yeah, that was the reason.
Yes, sir.
Nasana tabengi abantu balamba okusova just because amunamo feka namba mulyanza. Abengi balamba okupitamu no kusova bambinama na to the power babika mu to the power 4 ko afumishe 4 tawishibe just because namunamo amanza. So for them kutila, before you solve any of the Newton questions, please pishie any more pencil. Because the last law is just telling us that when there's a balance, when two bodies are resting, two bodies, one exerts 20 Newton in the other. What is the force that the other will exert in the other when they're interacting? Your answer should just be the same 20 Newton. Why? Because every action force, there's an equal and opposite reaction force. Today, I didn't really solve so much. As I've told you, I'm not feeling so well. But I'm not very fine. So mudembika kwa mapepo.